Hi, boys and girls. This is your instructional video for section 4.6, graphing equations in slope-intercept form, right? We're going to be starting on page 237 of your workbook. The I can statement: I can interpret the slope and y-intercept of a line from the equation of the form y equals mx plus b in order to graph the line on the coordinate plane. So basically what this means is we're going to give you an equation in slope-intercept form, and you're going to graph the line on the xy coordinate grid just from the equation. All right, well, we don't have an animation, but here's what happened. First thing, when you're given a slope-intercept form like this, the first thing you do is you place your first point on the y-axis using the y-intercept. Our y-intercept is positive 1. So the first thing they did was they put a dot at positive 1 on the y-axis. From there, you use your slope as directions to another point, okay? Because this is a slope of positive 2 over 3, that means that you will go up 2 and you will go right 3. Keep in mind that with positive slopes, you have an alternative. You can do negative 2 over negative 3, which reduces to a positive, and that would mean you would go down 2 and left 3. Either one of these will work to find you another point. Oftentimes, you have to use one or the other because of where the y-intercept is. From here, though, if we use this one, up 2, right 3, we move up 2 and then right 3 and place our second point here. Oftentimes, it's good to go ahead and make another point. They didn't do it here, but you could have gone down 2 and left 3 and put another point here. Sometimes it's easier to draw a nice straight line if you have more than 2 points. Then you draw your line through the point. Always remember that this is a line that goes on forever in both directions. Therefore, you should put arrows on it, and it should extend beyond the points. Okay. So example 1, graph lines using slope-intercept form. They want you to go ahead and graph this equation right here, graph this line. The first thing you need to think about is that this is your starting point. That's your y-intercept. Here's your y line, and so this would be 1, 2, 3, positive 4 goes right here. Okay. Now we have a slope of negative 2/3. With negative slopes, you can decide if you want the negative to be with the top number or the bottom number. Okay. If we're going to use this version, this says we go down 2, and it says we go right 3. This one says you go up 2, and this one says you go left 3. Keep in mind that the top number is always up or down, and the bottom number is always left or right. Up and right are always positive, down and left are always negative. So from here, if we want to use this one, this is down 2, right 3. We go from this point, don't go back to the origin, you start from your y-intercept, down 2 and right 3. That gives us a point. Likewise, we could have gone up 2 and left 3, up 2 and left 3. You can see that these points all lie on the same line. It's really hard to draw on this graphic tablet, though, and get a straight line. So I apologize for that. All right. That's how you do it. So now they want us to graph this one. Our starting point is positive 5. So we go positive 1, 2, 3, 4, 5. That's our starting point. All right. Our slope is negative 4. Well, any whole number has a 1 under it. So we're going to need a top and a bottom to find the next point. Okay. So since this is negative, we could alternatively go with positive 4 over negative 1. Right. But actually, this one wouldn't help us any because this would be up 4 and left 1. From here, we can't go up 4. All right, we run out of graph. We're going to have to rely on this one. This is down 4 and right 1. Okay, so from here, we go down 4, 1, 2, 3, 4, and right 1. You can do it again, down 4, right 1. And these, did I go down 4? 1, 2, 3, 4, right 1, yeah. And these will all lie on the same line. Okay. Now, one way to check to make sure you graph the line correctly is to ask yourself, what would Slope Dude have said about this line? Well, from left to right, Slope Dude would say this is a nice negative. Does it have a negative slope? Yes, it does. So since the slope matches the direction of the graph, you probably did it right. Now they go straight to word problems. Oh, well, part of this is cut off, isn't it? Well, I'll just move it up a little bit. How about that? Move it up just a smidge. Okay, there we go. A typical leopard gecko is 3 inches long at birth and grows at a rate of about 1/3 inch per week for the first few months. So they give us the equation y equals 1/3 x, and I hate how that x is so low. That should not be there. X is not in the denominator. It is a term next to the 1/3. Plus 3 represents the length y of a gecko after x weeks. Identify the slope. Slope is 1/3. The y-intercept is +3. So we start on +3, and with a positive 1/3 slope, the top number is up or down, so that's up. Bottom number is left or right, so that's right. So up 1, right 3. Up 1, right 3. 1, 2, 3. You could do more. Up 1, right 1, 2, 3. Up 1, right 1, 2, 3. Look at that. I got 4 of them on there. And then you draw the line. Now, notice I don't have the line going off with an arrow over here. The reason for that is my gecko will never be negative, what is it, years, months, weeks. My gecko will never be negative weeks old. He started at 0 and goes up. So that's why there's no other quadrant and why the line is a ray instead of a line, okay? Jaden has written 6 pages of his novel. He plans to write 4 pages per week until he has completed his novel. Graph the equation. So we have y equals 4x plus 6. That shows the total number of pages written y in x number of weeks. Okay, y-intercept is +6. So we put a dot at +6. Our slope is 4. Every whole number has a 1 under it. It says up 4, right 1. And here we go up 4, 1, 2, 3, 4, right 1. And we're not going to be able to get any more points on this one. Oh boy, it was worse than usual. And then we would have that line. Okay. All right. Still on page 239. The graph shows a horizontal line. All the points on a horizontal line have the same y coordinate. You can use the slope-intercept form of a line to derive the equation of a horizontal line. Well, if you have 0 for your slope, because a horizontal line is 0 fun, remember, because this is 0 fun. Then 0 times x is 0, so then you just get y equals the y-intercept, okay? Well, the y-intercept is 3. So you notice, in every case, all of these points have 3's in the y place. The x number can change, but the y place is always 3, all right? And that would be a horizontal line. So here we have y equals -1. You find where y is -1. Where else is y -1? Here, 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 here. And so you graph a horizontal line at y equals -1. It's not very horizontal, but you get that. Okay, here they gave you some example points. Any point where the y coordinate is -1 will be on that line. Any number in the front here, it doesn't matter. All right, y equals -6. So 1, -1, -2, -3, -4, -5, -6. It's going to be a horizontal line passing through. Y is -6. And now vertical lines. Vertical lines are the opposite. They always say x equals a number. All right, and they say you cannot use the slope-intercept form to derive the equation of a vertical line. That's because the slope is undefined, okay? It's sort of like breaking math laws. If we were to put the slope in front of x, there would be a 0 in the denominator of the slope fraction, and that is undefined. Therefore, it renders it impossible to represent a vertical line using slope-intercept form. You always just write it x equals, and then this number is the number that all the x coordinates will be in the vertical line. Notice all the x coordinates in this one are -2, so this is the line x is equal to -2. Okay, these are vertical lines. Here we have x equals 4, so we find on the x-axis, where is 4? 1, 2, 3, 4. They say to create points where 4 is a point, okay, 4, -2 would be here, 4, 0 is here, 4, 1 is here. You can see that we're creating a vertical line at x equals 4. Here we have x equals 7. So on the x-axis, 1, 2, 3, 4, 5, 6, 7. All right, we have a vertical line at x equals 7. Now we go to word problems. How fun is that? So we have the Garcia family, and their equation is y equals, I'll read you the problem. I know you're dying to know what's going on in this problem. I'm just pulling out the math. And then we have the Snyder family, and their y equals -70x plus 900. Okay? The Garcia family is driving from Philadelphia to Orlando for vacation. The equation, blah, 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 represents the distance y in miles the Garcia family has left to drive after X hours. Their friends, the Snyders, are meeting them in Orlando, but are driving from Cincinnati. The equation y equals -70x plus 900 represents the distance y in miles the Snyder family has left to drive after X hours. Which family has more miles left to drive after 7 hours? How many more? Okay. So the Garcias had to go 1,000 miles and are traveling at this rate. The Snyders had to go 900 miles and are traveling at this rate. So after 7 hours, so that means you're going to substitute 7 where the x is. So you have -65 times 7 plus 100. And then here we would have -70 times 7 plus 900. All right, so now we just need to solve this. Let me grab my calculator. All right, just need to solve this. Oop. Clear. 65 times 7, can't do that in my head, is 65 times 7 is 455. So we have -455 plus 1,000. All right. Means they have 545 miles left. Okay. Down here, the Snyders, well, I can do that one. 7 times 7 is 49. This is -490 plus 900. And 900 minus 490 is 410. The question asks, which family has more miles left to drive and how many more? Well, the Garcias have more left to drive. And how much more? Well, if we subtract 410 from that, we would have 135 miles for our answer. Okay. And now we have another word problem for a check. Safina is tracking the growth of 2 different plants for an experiment. The growth of plant A can be represented with the equation y equals 1/2 x plus 1, where y is the height of the plant after x numbers of days. Plant B can be represented with y equals 1/4 x plus 2. So you can see that this plant is actually growing faster than plant B. But this plant started out behind plant B. Plant B started out taller. Which plant is taller after 12 days? Well, 12 is the number you're going to substitute for x. So we will have 1/2 times 12 plus 1. Half of 12 is 6. So plant A will be, what, 7 inches tall? All right. Is it inches? I don't think it says. It doesn't say. Could be centimeters. Who knows? All right, over here, we're going to substitute 12. So we'll have 1/4 times 12 plus 2. Well, 1/4 of 12 is 3. And that's 5. So which plant is taller after 12 days? Well, plant A would be taller. Taller by how much? By 2. And we don't really know if it's inches or what have you because it didn't tell us. 2 whatevers. That is the end of the video. All right. Well, let's see. We need a secret word, don't we? Give me a second. Okay, I've got a secret word. The secret word is 1906. I know it's not a word, it's a number. The secret number is 1906. Don't forget it. Okay? And the question will be waiting for you over at McGraw-Hill. Have a great and wonderful day, and I will see you in class.